So the last thing we want to look at in this section is an application or two of our trig functions. And we opened this up by talking about how prevalent they are in everyday society. So let's look at the example we have right here. This is basically talking about the position of a moving arm and how if I were to graph that position and how it's related to the movement and the angle positioning, when I graphed it, you can see here that it creates what appears to be a sine function. Okay, so I'm going to make this just a little bit bigger so that you can see the actual graph, because this problem is coming at this a little bit differently. Here is the graph based on all the information in the problem. And what it's asking me for is, if I already know what the graph looks like, can you come up with the equation? We know this is a sine function because the sine function starts at the origin, has a max, crosses again, has a min, and comes back. From that, I can tell you what the amplitude is, and I can work backwards to figure out what b is. So let's try that. First of all, let's tackle the easiest thing. What's the amplitude on this? The amplitude would be how high up it's going or how low it's going. And we can see from the graph here that the amplitude is actually 1/3. The next problem would be, what is k? Or in this case, in all of the other things we've dealt with, in other words, what is b? Well, if I know that one complete period is 3/2, so if a period is 3/2, and to find the period, we take 2 pi over b, I can set these two equal to each other and solve for the missing variable. So I'm going to cross multiply. I get 3b is equal to 4 pi. Divide both sides by 3, and I get b is equal to 4 pi over 3. Therefore, I can come up with the equation that looks like y is equal to 1/3 sine of 4 pi over 3t. And that's the answer for part A. Now part B says, okay, well, how long does it take for a complete movement of the arm? What is that really asking you? A complete movement of the arm occurs in one period. Therefore, the answer to this would be the period, which is 3/2, or a better way to say that is 1.5 seconds. So if we're given a graph, then we can work backwards based on the graph to determine what the equation of that graph is. Okay, let's look at one more example. This example, they're actually going to give us the equation, and we're going to do some stuff on our calculator for this one. So let's walk through it. It says that the voltage of an electrical circuit can be modeled by this equation right here. The first thing I want to do is I want to be able to find out what the amplitude and the period are of this function. Okay, so the amplitude would be the coefficient next to the trig function, which is 5. Okay, what is the period of this function? Well, if b is 120 pi, then the period of the function would be 2 pi over 120 pi, which would be 1/60. So the next part of this question then says, well, how many cycles are completed in 1 second? 60 cycles can be completed in 1 second. The next thing it asks me to find is, if I know what t is, can you tell me what the answer to the function is? So if I know what t is, can you tell me what e is? So this is really just substitution into a table. So we're going to do that. If I know that the function looks like 5 cosine 120 pi t, and I'm going to substitute in these values, so for t and e. If I let t be 0, 0.03, 0.06, 0.09, and 0.12. Then I'm going to just plug these values in for t and get the corresponding values for e, and I'm going to record those on the side right here. So all I did was let my calculator give me back the values when I plugged in these numbers for t, and this is what I came up with for when t was these numbers, e was this. The last part of this problem asks you to graph the function. So I'm going to go graph this function, but I'm going to graph it using the following window. So on your calculator, we want to set your window to have the x values to have a minimum of 0, a maximum of 1 over 30, and we're going to increment that by 1s. For the y values, we're going to go from negative to positive 8, incrementing by 1s. So if you're not familiar with how to do that on your calculator, let's look at it now. So we're going to go to the y equals, and I'm going to clear out anything that I don't want on there, because I have a function in there already. And I'm going to graph the function that we were just talking about, which was 5 cosine 120 pi, which is right over here on the caret, t, only we're going to let it be x. Okay, so that's the function I want to graph. I want my window to be set to this over here. So I have 0 for x min. I've got 1/30th for the x max. I'm incrementing by 1. The y min needs to be negative 8. Max is going to be a positive 8, and we're incrementing by 1s again. So based on that, let's graph it. And your function should look like this. Okay, so that's what that graph is telling me, that the voltage in an electrical circuit is modeled by this amount right here. So let's take this over here, and we just want to make sure that we understand a couple of things about this graph and how our calculators can help us determine some stuff. Don't forget that on your calculator you can use the min and the max buttons to find out those values right there. You can also find the intercepts, which would be these values right here, there's a couple of different methods for you to be able to find the x-intercepts. Whichever method you're already familiar with is going to give you those right there. So we can take a function that maybe is a little outside of our range for graphing, graph it on the calculator, and then use the calculator to tell us the max and the mins as well as the x-intercepts for the graph. And these are just two examples of some real-world problems that represent both sine and cosine functions.